Hello, friends. Jim here. Well, this article appeared on the online publication EOS. When forests on land burn, forests underwater feel the impact. Kelp is a habitat, a carbon sink, and a binding agent in your ice cream. But new research shows that California's kelp forests are affected by the fate of their counterparts on land. Okay, what's going on? Here is a photo of giant kelp. Giant kelp is used in everything from shampoo to salad dressing and captures nearly 5 million metric tons of carbon dioxide each year. New research shows how forest fires on land affect the growth of kelp forests underwater. Just like forests, terrestrial forests, kelp forests has high biodiversity. Now, the giant kelp can grow 2 feet or 0.6 meters per day. Yeehaw. Sometimes reaching a length of 53 meters, about 175 feet. And inside all the kelp there, you've got kelp fish, kelp crabs, sea lions, seals, sea otters, like to wrap themselves up in the tendrils so they don't drift away while sleeping. And the important thing with sea otters is, they like to eat, shellfish, the mussels, and so forth. If the sea otter numbers drop, the mussels like to graze away at the roots of the kelp. And studies have shown that when sea otter numbers drop, the mussels just denude the kelp beds and you lose the kelp forest. So sea otters are important to keep the mussels in check, which then help the kelp forest thrive. Now, kelp describes several species of large brown algae. It's a crop. It's a carbon sink, right? As I showed you in the little headline caption there. Right? Now, it is harvested. It's a $500 billion annual industry. In large part, because it captures nearly 5 million metric tons of climate warming carbon dioxide each year. But they are temperamental, shall we say. They can have periods of expansive growth and periods of sharply reduced growth or high mortality. It seems to be impacted by what marine heat waves are doing, what ENSO cycles are doing, or just good old-fashioned storms. New research shows that forest fires in coastal watersheds also play a role. By comparing two data sets in an unexpected way, a team researchers is exploring how forest fire size relates to kelp beds downstream. And they presented some of their findings at the AGU meeting, the 2023 meeting in San Francisco. So what's going on here? After a forest fire, rain sweeps dirt and ash into the nearest waterway. When that excess terrestrial grit hits the ocean, it can both hurt and help the kelp. For one, the rich nutrients that wash downriver can help its growth, but cloudy water also reduces the availability of sunlight, which can stunt growing kelp stalks. In other words, they're not getting the light energy for photosynthesis. In addition, excess sediment can hinder giant kelp holdfast from anchoring to the rocky seafloor. If enough of the reef is covered in sediment, kelp can't survive, said Kyle Kavanaugh, a marine scientist at the University of California, Los Angeles. So they used two public tools, Landsat and SWAT, to study the connection. Landsat is a joint program of NASA and the U.S. Geological Survey. Its satellite imagery has captured California's coastline at 30-meter resolution since 1984. So we're talking basically approaching a 40-year data set. More recently, the Kelp project has also incorporated imagery from NASA's Sentinel-2. Kelp canopies are fairly easy to see on satellite images. Creating kelp maps requires pixel-by-pixel analysis, so that's what his group, along with collaborators from Woods Hole Oceanographic Institute, that's what they're doing. They make their data available on kelpwatch.org. So if you're interested in tracking that, you can go to kelpwatch.org right here, right? They also use the Soil and Water Assessment Tool, that's what SWAT stands for, a hydrology model developed by the U.S. Department of Agriculture. The tool tracks terrestrial traits like soil erosion, groundwater infiltration. By combining satellites with SWAT, the researchers can better understand how forest fires and soil erosion affect giant kelp. We often end up getting siloed by disciplines, said Christine Lee, a scientist at NASA's JPL, who co-authored research for Kavanaugh. NASA colleagues Mandy Lopez, Lori Asnev Barbarian, and Aaron Hestier of the University of California. So those are all the authors on the study. So they're basically trying to put it all together. Preliminary research shows there's an impact. The Woolsey fire, for example, burned nearly 940 million square meters in November 2018, sending sediment into Malibu Creek. Before the fire, the spring 2018 kelp canopy covered 46,606 square meters near Malibu. The following spring, kelp covered only 9,543 square meters and has yet to recover to pre-fire levels. Wow. The SWAT model estimated that Malibu Creek carried up to 1,721 metric tons of sediment per month after the fire. That's up to 1.3 times higher than pre-fire sediment loads and aligns with in situ observations from LA County. The multi-year study shows that wildfires have a secondary impact on kelp, but there's more to explore, more factors to consider. The Woolsey fire arrived after a marine heat wave and multi-year El Nino, and kelp is so naturally dynamic that it can be difficult to detect the effects of long-term and local factors, said Kavanaugh. So they're going through decades of data to try and find control sites along California's coast and in an attempt to isolate the effects of sediment. So what does this mean for kelp and coastlines? Now, SWAT may be a land surface hydrology model, but the study extends its results to the oceans. And that's something unique about this particular study, said Adnan Rajib, who is a computational hydrologist at University of Texas, Arlington, not involved in research. It's one of the first studies to connect the dots between post-fire hydrology and kelp, and it does on a scale larger than other SWAT studies. Usually studies on post-fire hydrology are very local. When you look at large watershed systems, that's when you have the total picture of things. So they're already studying several California watersheds and aims to scale their research globally. Giant kelp can be found along the coastlines of Chile, Mexico, New Zealand, Tasmania, in addition to California. And the frequency and severity of fires, marine heat waves, and so events are all expected to increase. Now, will nutrients from the forest offset warming in the oceans? Well, stay tuned, right? I thought this is a really interesting study because it looks at the non-traditional sea surface temperature and nutrient relationships for kelp said Meredith McPherson, an oceanographer at UMass Boston, not involved. So, the sediment load could provide nutrients, inorganic nutrients most likely, but it could also negatively impact by blocking out sunlight, causing increased turbidity, which we can measure with a device called a Secchi dish. And so if you have increased turbidity, photosynthesis rates drop off. It also appears to somehow impact the holdfast, basically the roots that anchor it to the rocky shore. If that gets compromised, they'll float away. So, like everything else, you got to compare the inputs and the outputs, the positive and the negatives. But the fact we saw that dramatic loss, what was it, some 46,000? Almost 47,000 square meters down to, say 9,500 square meters. Geez, that is a dramatic decrease. That's almost like basically an 80% loss. That's incredible. So that would seem to imply that overall the soot load, the sedimentation load, has a far more negative impact than any positives from any potential nutrients being introduced. And of course, why the increased sediment load? Because when you burn the trees and stuff like that, soil erosion increases dramatically. Everything just gets washed away, gets washed into the oceans. And of course, why are forest fires increasing? Well, the air is warming, can hold more moisture. It's drying out the ground. The grounds are more prone to igniting. So this could very likely be tied in to global warming as well. So be interesting to see if they expand the study to other localities, other coastlines, and to see where this goes further and what more their analyses reveal in the coming years. Until next time.